Good afternoon to everyone. Welcoming you all for the session 2 of day 2. This session is handled by Dr.N.Kumarappan, Chair IEEE Madras Section and Professor EEE in Annamalai University. I'm extremely happy to introduce our resource person, Dr. N. Kumarappan sir. Dr. N. Kumarappan received the graduate degree from Madurai Kamaraj University in 1982, the postgraduate degree from Annamalai University in 1989, and a PhD degree from CEG Anna University in 2004 under QIP Fellowship AICT India. He is the former head of department and currently a professor in the Department of Electrical Engineering, Faculty of Engineering and Technology, Annamalai University. He is having 33 years of experience to his credit as an educator and researcher. He has published more than 130 journals, international journals, and conference papers. According to Google Scholar, his citation is 1185 H Index 17. He was the outstanding reviewer for the Elsevier International Journal of Electric Power and Energy System 2015. He is an IEEE Madras Section Chairman, IEEE CIS Madras Chapter Chair, and a coordinator for more than 100 IEEE Madras Section organized FDP, workshop, tech meet, and TASP programs, etc. He was the recipient of the IEEE NNS Outstanding Paper Travel Grant Award, Australia 2002, IEEE WCC Outstanding Paper Travel Grant Award, Canada 2016, the IEEE PES Student Program Award, USA 2003, and the IEEE CAS Madras Chapter Best Chapter Award, 2017. He was also a recipient of Best Researcher Award, Annamalai University 2018. His interview has appeared in Electrical India magazine in February 2021 issue. He has acted as a guest editor in a special issue of Complexity Journal published by Veli Hindavi. He is a general chair for an international conference, MASCON 2021, organized by IEEE Madras section. His current interests include power system, operation and control, electricity price forecasting, EHV transmission fault diagnosis, fax device, power system reliability, artificial intelligence techniques, microgrid distributed generation, and smart grid. Dr. Kumarappan is a life fellow of the Institute of Engineers India and a life member of the Indian Institute of Technical Education. He was a recipient of IEEE Madras Section Motivation Award in 2010 and a Certificate of Appreciation in 2012, third rank in a chapter activities 2015. He was the organizer of a special session in IEEE WCCI 2010 Spain, IEEE WCCI 2016 Canada, IEEE WCCI 2018 Brazil. He is a speaker, reviewer, and a session chair for IEEE IET UK International Conference and other international journals. We are honored to have you as a resource person, sir. We welcome you, sir. Now onwards, the session will be handled by our resource person.
Good afternoon to all, dear organizers of this program, Dr. Meena Lochini, and dear participant of this faculty development program. Very happy to participate and make a presentation on one of the topic related to the smart grid. Now I share my slide. Is it my slide is visible?
Yes, sir. Yes.
Right. So the title of the talk is Intelligent Unit Commitment with Vehicle to Grid using Hybrid Optimization Technique. Over the beginning of the inauguration, the time of inauguration, I mentioned about a different kind of grids. The most continuation of that is today's presentation. Now, again, recalling that one in a very short time, the olden kind of AC grid now is changed as AC-DC grid. And that now we are in a position to solve all kind of a problem only for the AC/DC grid. Even in future, you can expect a DC grid. At that time, maybe Thomas Alva Edison's dream may be satisfied. And therefore, now we are only have an AC/DC grid. The problem to be selected and to be solved only suitable to AC/DC kind of a system. And beyond all that, the microgrid, you already heard a lot on that based on 3 previous presentations. You know more about microgrid. Even to produce a small amount of power, we always use a microgrid that may be connected to the main grid. Otherwise, it may be connected to it may be acted as an isolated mode, both possible. And the next one is smart grid. Smart grid required a re-engineering the present system to be changed completely. What is the way? Now we have only one directional flow of power. Now that is to be changed as bidirectional flow. And not only that, parallelly we require a communication line. That is also must be a bidirectional. So once we understand if it is bidirectional, where there may be an excess power, that may be shared very easily. It is similarly like sharing a water, making the river as a nationalized one. Where there may be an excess water, where there may be a water may not be available, it is may be easily shared. Similarly, we can share the energy, but that too electrical energy. Once we share such kind of things, we require a grid that may be not a nationalized grid, it may be a smart grid. Smart grid is nothing but managing the energy in a perfect way. That's all. It is nothing but managing the energy in an intelligent way. That's all. Therefore, once you want to make the grid a smart grid, we are in a position to make re-engineering and make it as a bidirectional flow of power. Now, those who study power system, they know them very well. The bidirectional flow of power is already existing on the system. Where exactly it is existing? That is my question. Therefore, if it is exactly existing in some other places at present, then it is very easy for us to even to form a smart grid. Such a kind of thing already existing. It is called as interconnected system. In the interconnected system, the flow of power may be bidirectional. Therefore, the line is called as a tie-line transmission. From that, it is clear one region to other region, we make connection. That's interconnected network. In that interconnected network, the transmission line is called as a tie-line transmission. Therefore, there might be a bidirectional flow of power. You can give the power, take the power. Then only you can connect with the other region. Not only that, we are concentrating even on the frequency in the interconnected system. Though you want to synchronize one region with other region, you have to maintain we are in a position to maintain the same frequency. Then only it is easy for us to synchronize. Such a way we do it, we can easily form the smart grid. And one more grid I introduced in the inaugural session, supergrid. It is possible only we make an international kind of a data as a common one. Then we can easily make a supergrid. So one continent to other continent, one country to the other country, you make a supply of power. That is exactly called as supergrid. Okay. Even we make a visit to other country, we always go with adapter. Even that may be even a universal adapter. Therefore, once we go with adapter, we understand. For example, US is 120 volt, our country we have 230 volt. That way we are differs. Even the frequency also differs. 50 hertz, they are maintaining 60 hertz. Such a way we are differed. Therefore, it is very difficult to do once this kind of a concept may not be make it as a internationalized, a common kind of a data. Then only it is possible for us to make the grid as proper grid. There is a big challenge in front of us. Now, related to the smart grid, what is the way our presentations are helpful? We are managing the energy in a smart way. Not only that, at present, it is to be managed with the green power. We are in a position to avoid completely the olden kind of a generation, or otherwise conventional kind of a generation. The conventional kind of generations are called as thermal power, nuclear power, hydro. Because hydropower is okay, but remaining all is really a pollution. So due to nuclear power, radiation happens that affects our health. Due to thermal power, plenty of emissions coming out through the thermal plant that affects a lot. We are in a position to concentrate on that. Previously in the thermal plant, we only concentrate on SO2 and SOx and NOx in O2. We always prefer a low sulfur content coals. Through that, we avoid SO2. Now we are in a position to concentrate on CO2, carbon emission. The reason is tons and tons of carbon emissions coming out through only thermal plant. Therefore, it comes out like continuously. Finally, it reaches to the global warming. Even it continues, it becomes ice age. The ice age no one can live. From that, we understand now we are in a position to sacrifice thermal plant even based on the cost wise. Then only we can run this earth for a long time. The survival of the fittest, not only for the animal, now for the human being. Once you avoid such a kind of a pollution, then only the survival of the fittest of the human being decided. Therefore, now we are in a position to that. We are now eliminating the thermal plant completely. Therefore, from that we understand with the green energy how we are going to manage smartly. Particularly, we even use electrical vehicle. Once you concentrate in the electrical vehicle, even after a few years, it may be around 10 years, there may not be a petroleum kind of a vehicle running on the road, only electrical vehicle. There is a plenty of charging stations also available. Once you have electric vehicle, it may be useful in two ways. One is it supplies power, vehicle to grid. Once you want to charge the vehicle, then grid to vehicle. Once you supply the power, it discharges grid to vehicle to grid. If you want to charge the vehicle, grid to vehicle. Therefore, that way, the electrical vehicle may be used for two different kind of way. One for transporting, other one for transmitting power. Both the ways it may be helpful. Therefore, it moves and supplies. Very important thing. Once you use this kind of regular technologies, it moves and supplies the power. Right. Okay. But that is the importance of electrical vehicle. Now, using such an electrical vehicle, how you make it a green energy, not only that, and how you manage particularly the peak load. The peak load, even if you supply a small amount of a kilowatt, it becomes off peak. Our aim is to make the peak load as off peak. For that, how our way of presentation may be very useful. Once you make a commitment, you have to make intelligent commitment, intelligent approach-based commitment, intelligent method-based commitment. The reason is always in the intelligent method-based. First, the preference given to the electrical vehicle, then only the remaining convention. Through that, you are avoiding the thermal plant completely. At the end, you don't, particularly the peak load, it is not possible for to avoid. At that time, you are in a position to use a thermal plant, but you use a vehicle, only use for initially electrical vehicle. Almost it acts as a green energy. Therefore, that is the way we can make a commitment intelligent based on the intelligent method that too by a different kind of optimization. Now here, I prefer a hybrid optimization technique. Well, once you mingle the two optimization techniques together, from that what you understand, the weakness of the two methods are eliminated. The strength of the two methods are added. So that way you get the hybrid algorithm. Particularly here, it is hybrid optimization. The strength is added, then what happened? Trapped into the local optima can be avoided. Only global optima till the end. Once you make hybridization, because sometimes use an individual algorithm, may trapped into the local optima. To overcome that one, always to maintain a global optima, we require a hybrid kind of algorithm. That way, the hybrid kind of algorithm may be very helpful for us. Based on slide-wise, and make movement of the slides through slide-wise presentation-wise. The present scenario, increasing electricity demand, is mostly met out by thermal power plants. Now we are no other way. At present, it's not possible to avoid thermal plants all of a sudden. But now we are in a position to going on using thermal plant. In future, we have to concentrate no more thermal plant to be not to be installed, as well as with what are all the thermal plant with us try to utilize as minimum as possible. Generating units in the plants has to be properly committed to meet the load demand and also to reduce operating costs of the unit. Therefore, generating units in the plants have to be properly committed. All the units should be properly committed and meet out the local load demand and also to reduce the operating costs of the unit. Once you make a commitment, again you are saving the cost. Therefore, first, by the way of dispatch, what you understand, once you make a dispatch, again the fuel is saved. There's a three different kind of a generator. One of the generator running with only with the minimum load. It's not minimum generating well. It's not below minimum. It's not possible to run the generator. Beyond maximum, also not possible. Below minimum, run the generator. There is a great loss. Therefore, from that we understand we have to run the generator between minimum and maximum generations. That is the way once you make a run, then based on the load demand wise, each and every value to be dispatched between minimum and maximum. Once you optimally dispatch, through that you can save the fuel, the utilization of the fuel. Through that you can save the cost. That is the way we always do it. But a unit commitment is different. Among all the available generator, which unit to be committed based on the demand? Only at the time of peak load, all the unit to be committed. But other than that, it's not necessary to commit all the unit. Not necessary to waste it. First decide the commitment. You have 24 generators. Only you make a commitment of 5 based on your load. But that is through that again you are saving the cost. Once you decide the 5, again make a dispatch. Through that again saving the cost by the way of saving the fuel. That is the way we always do it. Therefore, to reduce operating costs of the unit is our main concentration. Reduction in fuel costs is achieved by allocating the units properly. Therefore, reduction of the fuel is achieved only by you are allocating the unit properly. Vehicle to grid technology drawn interest in recent years on unit commitment to reduce the running cost of the unit by properly allocating the vehicle in inconsistent parking slot. For example, you take your electrical vehicle for your working place. Once you reaches the place, all the vehicles are to be parked in a parking slot. You try to utilize all the vehicles together to make it to generate a power. That way you can commit. Going on adding one by one, all the vehicles going on adding. Through that, the kilowatts are going on added. How many number of units you are going to design, maximum number of electrical vehicles based on that, the power generated from that is going out. Once you make based on optimal kind of a way, first of all, avoiding all kind of conventional kind of things. Going on allotting the vehicle from available on the parking slot. You make a commitment. Once you committed, then the particular power based on the load demand, you can make up the power easily. It is saving of the fuel by the way of minimum, by the way of using minimum units as well as by the way of dispatching. You're always reducing the fuel costs. Output of power of generators will be reallocated in the consideration of the vehicle power to grid. The output of generator will be again reallocated. Therefore, based on the vehicle power to grid, what is available to the vehicle, again reallotted continuously, such a way you can do it. Then the outline of my talk continues. Each vehicle is considered as a small portable power plant. S3P, small portable power plant. Portable 1P, power 1P, another plant 1P. That's why S3P for supplying power to grid. Now the unit commitment become complex constraint problem. This problem is optimized by using the particles form optimization. Here I prefer a particle swarm optimization. And not only that, hybrid PSO used to optimize optimal allocation of the vehicle to be connected in constrained parking slots. Therefore, based on this hybrid PSO, how many number of vehicles to be selected at that particular load pattern, particular load pattern in a particular hour. That way, we always make a commitment. Finally, we get 24 hours commitment based on the 24 hours load pattern. In this project, improved binary PSO and the boost searches combined together to optimize the status of the unit in binary form. Now here the binary PSO and the double search combined together to optimize the status of the unit to binary form. Okay, I already told you, comparing these together, the weakness of the two methods are eliminated, strength is added to it. And once it is added, then it may not trap at the local optimum. Escape from that, always maintain the global optimum. Therefore, ELD is calculated using the PSO. Again, using a PSO, we make a dispatch. Objective is aim of my paper is to introduce the gridable vehicle into the power system grid for intelligent unit commitment in order to reduce operating costs and emerge emission, also to increase the reserve power capacity. Reducing the operating costs, I already talked a lot through that. You can save the fuel. And by the way of minimum usage of the unit, also you can save the fuel. Beyond that, emission, once you reduce emission, what is the way the cost is saved? You're avoiding the penalty. Based on that, the cost is saved. And that is the way we are reducing the operating costs as well as emission costs. Also to increase the reserve power capacity. Therefore, the reserve power capacity. Otherwise, only you concentrate avoiding the penalty cost, we are reducing the emission, that's all. Beyond all that, reserve power also plays a very important role. You have to maintain the reserve power continuously. Based on your reserve power, it works appropriately. Therefore, any problem happen, we manage with the reserve power. That way, the system's reliability is maintained in a nice way. It may be maintained even with one index, maximum as one index. Therefore, you're maintaining the index as maximum as one, then through that, we're maintaining the reliability. That is depends on the resource capacity of the unit. Therefore, that also we concentrate here. Introduction. Unit commitment is a very significant task in daily operation and planning of power system. The main aim of the unit commitment is to schedule the on-off status of the unit to meet the forecasting load in a day, which include many constraints to be satisfied. Also, an operating cost of the unit has to be minimized. Therefore, not only we are making a dispatch of unit commitment in an appropriate way, the unit commitment decide based on the on-off status. And beyond all that, we make a schedule that to based on the forecasted load. And it is all to be done with a different kind of constraint, subject to number of constraints. According to operation research, you know the problem. Minimization or maximization is subject to number of constraints. You satisfy the constraints also parallelly. Then only the problem works perfectly. Some of the methods to solve the unit commitment are as follows. Once you have a look at the conventional kind of methods, the optimization technique for unit commitments are called as priority list method. The next one is branch and bound method. Third one is Lagrangian relaxation. These are all mathematical approaches. Next, meta-heuristic method is exactly as a computation intelligent method or soft computing method. Otherwise, artificial intelligence method. Now the latest name wise natural inspired computing methods. Meta-heuristic methods is called as GA, genetic algorithm. The Bosearch evolutionary programming, EP, simulated. Even the nature help us a lot to produce a GA and even neural network and evolutionary. But beyond all this human nature wise we get different kind of algorithm, genetic algorithm, neural network, evolutionary. But making annealing process, we got the algorithm. That's called simulated. Making the swarm's nature, we got the algorithm, particle swarm optimization. Make is the nature of ant, we got ant colony algorithm. Making the nature of bee, we got bee colony algorithm. Like that, number of algorithms. Even there is a innovative algorithm called as teachers learning. Once, what is the way the teacher make the learning? That itself become an algorithm. And based on the intelligent approaches, just a minute. Based on different kind of natures, we get a different kind of an algorithm. I already listed a number of algorithms to you. The swarm-based algorithm now here selected as ant colony optimization, particle swarm optimization. The ant colony optimization, it is memory and computational algorithm, especially dealing with large scale optimization. So when these intelligent methods are very helpful for a large scale problems, and not only that, for example, even the lambda iterative method is a very popular method to solve the up power dispatch. But beyond that, how the intelligence are better? It's a question. Some of the problem not possible to be solved by the lambda iterative method. Examples are non-convex problem. Therefore you get non-smooth curves based on that. Such a kind of a non-convex problem cannot be solved. Non-differential cannot be solved. Therefore, once use differential kind of things, otherwise not a smooth curve once you got it. Such a kind of a problem can be solved only by using the intelligent approach. Therefore, once you form the load patterns and there is a jump on the curve, that's called non-smooth. When the jump it happens due to the fuel, due to once you inject the steam to the turbine, opening the steam valve, sometimes steam may not be available, the jump can be happening. That is a practical kind of such a kind of non-smooth curves once you form. To solve such a problem, we require an intelligent approach. ACO is a memory and computational algorithm, especially dealing with large-scale optimization. Therefore, PSO, it is less space consuming, simple and efficient. Therefore, the commitment with V2G, Bagel to Grid. Bagel to Grid technology becoming a popular in recent days, and it is regarded as an application of SmartGrid. So Bagel to Grid is application of SmartGrid. So from that, we understand where this is very useful, the way of SmartGrid. Once you study about it, it may be very useful to utilize in the SmartGrid by using the new generation electric vehicle, but supplying the power to grid. Therefore, from power to once you have a vehicle, through that you can supply the power to the grid. But that time it may be vehicle to grid. Then at that time it discharges. Once it discharges, again the vehicle to be charged. You can charge using a charging station. In future, we can expect plenty of charging station. But at present, the main disadvantage is charging. It takes long time. In future, there is a plenty of researches going on. Now, even the research is called far field charge. Only on the move of the vehicle, you can make a charge. So that you can make a fast charging. That may be possible in future. Once we attain such a kind of a thing, electric vehicle popular like anything. By using the next generation electric vehicle for supplying the power to grid, proper allocation of S3P with the existing generation unit, reduce the emission and operation cost of the unit. Right. Therefore, based on this S3P and small portable vehicle, once use S3P with the existing generation unit, reduce emission, and not only that, it reduces operating cost. Unit commitment with vehicle to grid increase the spinning reserve capacity. Though because of using a plenty of vehicle, you can increase the spinning reserve. Once you increase the spinning reserve, from that what we understand, we can maintain the reliability. Now this may be the parking slot. From the parking slot, how the power is supplied is given clearly. Vehicle power connected to the grid. The above figure 1 shows how vehicle power is connected to the grid. According to the power demand, vehicle output is varied in accordance with the generating power to satisfy the loads. Therefore, HPS4 hybrid particles is used to optimize allocation vehicle to a proper slot. From using HPS4, how many number of vehicles to be utilized, you can decide based on the optimization. Then it is supplied to the aggregator, then to the grid. Such a way it supplies. Right? Problem formulation is objective of the unit commitment with V2G is minimizing the total operational cost and emission, where cost is improved main fuel cost and startup cost. Right? Therefore, I already explained about the main cost of the plant. Now, with that, we add the startup cost from actual problem formulation. The fuel costs of the thermal unit expressed as a second order function. Now, the FC of PIFT is equal to, in terms of PICA, all are cost coefficients. PI is represented as a scheduled power, right? The same scheduled power can be utilized for emission also. That way, you are in a position to compromise. That's called trade-off. Once the fuel cost is reduced, emission may be increased. Emission is reduced, fuel cost may be increased. That's why we require a compromise. That's called trade-off. We always get the solution based on the trade-off curves. Emission curve is expressed as a polynomial function in order to depends on the desired accuracies. Again, the above one is a quadratic cost function. This is a quadratic emission function. Here the emission coefficient differ from that alpha, beta, and gamma. That is a bit different. But schedule-wise, the scheduled power is one of the same in fuel cost as well as calculation emission. Now startup cost. Simplifying the startup cost applied as follows. Therefore, once you decide the H cost, what is the way? Based on minimum uptime and downtime, H cost and C costs are decided. Therefore, we start the thermal plant, we require a particular time. That's called minimum uptime. Once you want to shut down, you require a particular time. That's called minimum downtime. Based on that, we always decide the startup cost. Once you decide the startup cost, that is to be added with the main cost. Shutdown cost. Shutdown cost of each constant and typical value is zero in standard system. Okay. Now we consider as a zero in shutdown cost is zero. Always we understand shutting down is a loss measure. Therefore, the main objective function for cost emission optimization unit commitment with V2G is this one. First, we add the startup cost of the fuel together and multiply with the weighing factor. Similarly, the emission, another weighing factor, because this unit is different from this unit. If you're adding the two units, you require a weighing factor, WC and W. This weighing factor added together, you have to decide one. For example, this may be 0.7, this may be 0.3, this may be 0.5, this may be 0.5. Like that, you have to decide. Therefore, that way, weighing factor to be decided. Now, the weighing factor with the exact variable values. Therefore, the fuel cost with respect to the scheduled value plus startup cost, deciding the status on off. If it is off, there is no person startup cost. Only on the startup cost added with this. Then, based on the status, again the emission penalty is decided. Based on the emission, we calculate, we multiply with psi, get the penalty. That penalty cost added with the weighing factor. And adding this to the making a summation by the way of I is the emission penalty unit time. WCW are weighing factors. So constraints of the unit commitment V2G is a vehicle balance in UC with V2G. Only a predefined registered gridable vehicles are considered for the optimal schedule in unit commitment with V2G. Therefore, predefined registered gridable vehicle is considered for the optimal schedule in use with V2G. Therefore, vehicles are charged by renewable energy sources and discharges to the grid is predefined scheduling period. Right? Once you use one vehicle at a time, you may not use again because that is to be charged again. That's why you have to design how many number of vehicles you are deciding initially, maximum vehicle. That is decided here. NV2G, VV2G maximum. That by how adding on, going on, adding all the vehicles, you get the maximum vehicle. The charging and discharge frequencies. Depending on the type of batteries used in the vehicle, for charging based on the lifetime and the batteries multiple charging and discharging facilities a vehicle were considered. If one vehicle is fixed in a schedule of 24 hours for discharging power to grid, only during the corresponding hours vehicle is used. Therefore, in simple words, a scheduled vehicle is used only one time a day. From that, it is very clear. Because after that, it is to be again to be charged. Therefore, charging and discharging to decided appropriately. That is the way we can reuse the vehicle again. Otherwise, we are in a position to use the vehicle based on the number of vehicles, certainly only one at a time. That is called as charging and discharging frequency. That is also acted as one other constraint. System power balance. Power supplies from the committed units are selected some percentage of total vehicle. S3P must satisfy the load demand and the system losses, which is defined as, therefore, it is nothing but equality concept. Once at the particular demand, you have to meet out the power plus the loss, both together. Then only it's called as a system power balance, otherwise equality constraint. Now it is given in the form of equation based on the status wise. Units are added, status specified by IFT, and schedule is PF. Now based on the number of vehicles we're utilizing added together. These two added together, what is the way it is to be meet out exactly the demand of the power plus losses. Once you meet out that way, the equality is balanced. The equality is satisfied. Spinning reserve. Maintain the system reliability. Adequate spinning reserves are required. Now we are in a position to add the spinning reserve. Apart from the power demand, we are adding the spinning reserves. That is the way the equation changes again. Generating limits. Each unit has generating limits. Let's call the condition, otherwise inequality concept. Now the generator value decided between the maximum and minimum of particular generator. Similarly, for all the generators, value decided between minimum and maximum, because you can't run the generator below minimum. It's a great loss. You can't run the generator beyond the maximum. For number of discharging vehicles, that is also to be decided. All vehicles cannot be discharged at the same time. For reliable operation control, limited number of vehicles will discharge at a time. How many number of vehicles you are going to discharge? Otherwise, make a supply to the grid. That is also we decided based on this constraint. Next, minimum of pump downtime. Once a unit commitment or uncommitted, there is a predefined minimum time after it can be uncommitted or committed respectively. That is a way based on the commitment and non-committed values can decide again. That is again also based on minimum of up and down time, and as well as based on the status line. It is to be decided. Initial status. At the beginning of the schedule, initial state of all the units and vehicle must be taken into account. And now particles form out. Particles form out once I have an iterative method. Velocity and positions of the particle is calculated as follows. Now these are all the velocities, VIG, size of velocity. And randomly you can decide V best based on the position wise. This is the X is a present position value. C2 and C1 are problem dependent parameters. From that you decide the position as well as based on G best wise. Now velocity wise, the position values are added and then by making a delta addition, delta increment. Then you get a new position value. First term indicates current velocity of a particle. Second term indicate current, first term indicate the current velocity of the particle. Second term indicate the cognitive part of the particles, where particle changes its velocity based on its own thinking and memory. This is the second part. Next one is the social part of the PSO, where particle changes its velocity based on social, psychological adoption, knowledge of derived from the song, right? Therefore, that way you have to decide. And going on, making a change on the method, right? These are all problem-dependent way how to make a change. And binary PSO. Here we not only select an ordinary PSO, it's a real coder. Now it will be prefer a binary because commitment you require only 0 or 1. 0 means not committed, 1 is committed. Schedule thermal limit in a binary optimization problem. A continuous searching space can be converted into valid binary searching space by probability distribution. Based on the probabilistic in nature, you are deciding the valid binary searching space. All the intelligent methods, what we are doing, we are designing this searching space. Your searching space are small, you can easily search, that's all. This making it small depends on the algorithm, wise it differs. That's all. To extend the real valued PSOs to binary space, calculate the probability from velocity to determine whether the XIJT will be on off status. And based on that, you decide the position. And the value will be generated between 0 and 1. VIJT is a random value, that is a velocity value. If VIJT is a greater than random value, what to do? That PF velocity, P velocity wise 1 by 1 pi 1 plus exponential minus VIJT. From that it is very clear. Compared to the numerator, denominator higher quantity. Always lower by higher, the value compressed between 0 and 1. Let's call on all the intelligent methods, call it normalization. Through that, your searching space reduces between 0 and 1. Similarly, here also we do searching spaces reduces 0 and 1. When we decide 1, where u of 0 or 1 less than the fitness value, then we decide 1. Otherwise, it is 0. Otherwise, it is 0. Then the improved binary PSO. Now we make an improvement in the binary. It will be helpful for us to the convergence algorithm. Some of the shortcomings in the binary PSO is overcome by improving the binary PSO. An individual in this method is bit string, which starts a trip from random point in search space and tries to become nearer to the global best position of itself. Therefore, now nearer to the global and best position we are going on, decide. For that, we will make a slight improvement in present algorithm. What is the way? The process of generating new position of the selected individual in the sum can be represented by. What is the way it's represented? B best is making a bounded product with WI. Next is bounded sum with this. Otherwise, weighted product, bounded product with the G best. Again, the G best is at bounded sum with position. Finally, with the bounded value, the position bounded value with the velocity. That way. Now, this is bounded values, so decided based on and operating or exclusive operations. The plus is the OR operator, W1 and W2 are two random binary integer numbers uniformly distributed in the range of 0 and 1. That is the weight x. And the velocity vi will determine the probability threshold. If the velocity is higher, the individual is more likely to choose 1 and lower value power 0 choice. The threshold is calculated by a sigmoid function, which is defined as follows. Based on this threshold value, everything works. Already told you, this is a fitness. Lower value divided by higher value, always get value compressed between 0. That's called normalization. Now, the constraint management, a direct repair for constraint of unit commitment with V2G is given below. What is the way? If the total number of vehicle is not satisfied, Difference between the left and right side of the vehicle. Therefore, you decide how many number of vehicle from left to right is randomly distributed among 24 hours. System power balance, generator limit, and ramp rate constraints are satisfied in primary dispatches unit commitment with feature. Therefore, once you consider ramp rate, it's exactly a practical kind of a problem you're solving. Therefore, nearest valid limit is assigned to your inequality. Therefore, you have to assign inequality constraint values means this may be a practical value. Taboo search. Taboo search is based on procedural design to cross boundaries, local optimality, imposing and relating to constrained systematical mark makes it is possible to search areas which cannot be searched by traditional methods. The algorithm derives from the supposition that bad strategist choice can yield better, more information than a good random choice. The Taboo search is based on the local search. The searching point moves the best solution other than best solution at present of all neighborhoods. In this time, it is not a problem that whether the next solution is better than the best solution at present or of not. Moreover, to prevent the cycling, the searching is set up that movement is to fast solution, the Taboo search. So what do you mean by that? Among the random search, you get a best solution around 20. And among the 20, you filtered it, finally got only best one is 7, top 7 based on the sorting out. The way you get top 7. You select the top 7, make it in the double list. You utilize that top 7 only for the remaining generation, otherwise remaining iterations. Then you get the best solution. That's called the combined, otherwise hybrid algorithm between Taboo and PSO. The proposed PSO Taboo search method. Attention to following power points Taboo search used to achieve a global search of the solution space. Moving away from a present best solution, taking a change for the worse, it allows in search process. The algorithmic memory is information of the past solution is double list. I already told you. Best one is moves on to the double list. That double list value to be utilized for the further iterations or generation. If the double period passes, double states were released and the memory is deleted. Once the double states released, and then what happened? Double period passes, only the states were released and the memory is deleted. It's ready for the next iteration. Now the algorithm. The proposed algorithm for unique commitment with feature G. Set parameters with improved binary PSO and double search. Initialization n+1 iteration matrix for each particle randomly. Next step 2. Call fitness for each particle using equation 1 and find P best and G best among the particles. Such a way you can try to use it. Find out the B best and G best. Calculate the velocity using G best. Then update the current position using 2 to 4. Now 1 and 2 to 4 back go back and record the slide, which is 1 and 1, which is 2. And the first one, the beginning of that you have seen that one is this one is a 1. The minimization, this is adding with the vacuum factor, minimizing the fuel cost and emission. That is the first objective. That is equation number 1. Now 2 to 4 is a method-based analysis. Now we have to look out the 2 to 4. This is a 2 to 4. Therefore, based on the velocity wise 2 and 3 is decided. 4 is a fitness. That is the way all the 2 to 4 are decided. Okay. Now calculate the fitness for updated particle for finding B best among them. Once you know the fitness, calculate the B best. Now the f of B best is less than f of G best. Then decide the G best is B best. Applying double search. Once you decided, apply the double search. Fit the particle other than the global best, G best in the double list. Perform the double move to particle double list. Therefore, perform the double move the particle double list. Calculate the fitness for the mode double. Check if the double mode less than or equal to if global. Then mode double is global best. So global step is used. Global best is used in all double mode away from the double list. Get use a value of a global best. And from the above and get step 4 until the stopping criteria is satisfied. Maybe stopping criteria is based on the optimality achieved, otherwise maximum number of iterations you decide stopping criteria. Now we almost come to the conclusion. What is the conclusion of my presentation? Unit commitment with V2G will give better reduction in operation costs and emission than normal unit commitment optimization. Also, considerable amount of a spinning reserve capacity of the unit will be increased. Therefore, V2G use one vehicle together with we make a commitment. All the vehicles are available in the parking slot. You can go on to select it initially, make a commitment of all as possible as maximum vehicle. Then the remaining loads, you meet out the remaining loads. We always use a conventional kind of energy. Through that, again, you're saving fuel and commitment of that. Through that, the emission is again reduced. Also, considerable amount of spinning reserve will be increased. Because of this, spinning reserve increases. What happened? The reliability of the system is increased. So that you are maintaining reliability index. So you can avoid blackouts. Abroad, the blackout it happens very difficult to manage because even for quicking and climbing steps, they require power. But in our country, without power, we can easily manage. But that people it's not possible. From that, it is very clear. You have to manage or balance things appropriately. So that we give a very clear cut and a very smart ideas. And not only that, using this, you can even form the grid as smart grid. Therefore, once you form the smart grid, it may be very helpful for us. With that, I'll come to the final conclusion of my presentation. You have any queries or questions? I'm happy to answer. This kind of online presentation, compared to presentation questions, plays a very important role. And only your understanding capacity may increases.
Any clarification required for the participants?
Any questions? I'm happy to answer. Otherwise, no problem.
Thank you, sir, for such a subjective and informative presentation. Hereby, we have come to the completion of two-day IEEE Madras section sponsored faculty development program on Smart Grid Trends and Future Perspective. I would like to call upon Mr. T. Pasupati sir, Assistant Professor PCE, come IEEE STB in charge to deliver the vote of thanks.
Thank you, Atyasri. Good evening to one and all gathered in this platform. It's my great pleasure and my honor to propose vote of thanks on this wonderful occasion. First of all, I would like to thank our management, secretary, and the principal for motivating and permitting us to conduct this kind of wonderful programs for the benefit of faculty fraternity. Next, I extend my heartfelt thanks to IEEE Madras section for the financial support. Also, I extend my thanks to Dr.N.Kumarappan sir, Chair, IEEE Madras section. Thank you, IEEE Madras section. Next, I extend my heartfelt thanks to our resource persons, Dr. M. Venkatakritiga, Associate Professor, IEEE in National Institute of Technology, Tiruchirappalli, Dr. M. Meenalakshmi, Assistant Professor, IEEE of King's College of Engineering, and Dr. Arul Raj, Assistant Professor, IEEE of King's College of Engineering, and Dr. N. Kumarappan, Chair, IEEE Madras section, and Professor, Electrical Engineering, Annamalai University, for their valuable lectures on smart grid trends and future perspectives. Thank you, professors. Next, I extend my thanks to Dr. M. Meenalakshmi, Assistant Professor, also the coordinator of this program. She has taken great effort towards the success of the program. Thank you, ma'am. Next, I extend my heartfelt thanks to Ms. Lakshmi, student of final year ECE, for moderating the whole program. Also, I thank enthusiastic participants from our colleges and other institutions. Thank you, participants. Finally, I thank Mr. Narjan Samuel, JR of King's College of Engineering, for his technical support in broadcasting this event. Finally, my big thanks to one and all gathered in this platform. Thank you. Thank you, everyone.